Okay, good evening. You can hear me, you can see screen. Okay, good. Uh, so today we will do this question, which is a Robot C program. Okay, so recently, Carol is spending a long time waiting at Toronto Airport. How to efficiently handle baggage, and since she can use a Lego robot to do this, she has modified the standard configuration so that the suitcase cart will be towed by the robot. Okay, so you will have um, the robot driving the suitcase cart. Okay, and this is our robot. uh, the color sensor um, has been modified to the cart so that it detects color. So we have color sensor connected to sensor 1. With no suitcases present, it will give color 0. So no suitcase, color is 0. Gyro is connected to S2. So we have gyro connected to S2. We have ultrasound or ultrasonic connected to S3. Uh, this is the configuration we have. The wheel radius is 2.75 centimeters. So this is constant. We can use this for converting the encoder counts to distance. So each suitcase will have a label with a color. The color will be the destination airport, which is a drop-off location, and the drop-off locations are 10 meters from the starting points. Black, which is color 1, it is 10 meters away. Um, Brown, which is color 7, it is 70 meters away. So it is clear that the distance is 10 meter multiplied by the color. So if the color is black, it will be 10. If the color is brown, it will be 7. Then we have red in between, blue, and whatever. And you know that these colors are constants and it's an integer value. So the robot is initially placed at the starting point, and we need to write the program to do the following. Okay, so this is what we need to do in this code. Let me just move this down. Okay, so we need to do a program to do the following. First, state at least one assumption. What is an assumption here? You can assume. What is an assumption here? Yes, so robot faces this direction. Okay, so assumption, so assume robot face correct direction. What is another assumption here? Can happen. This is not an assumption, Koketsu. This is not an assumption. Okay, this may be an issue or a challenge, but this is not an assumption. Okay, assume colors are valid. Okay, what else is an assumption? Okay, assumption that we will stop the robot at the distance. Okay, so this 10 meters is for the robot, not for the suitcase location. This is an assumption because we will focus more on the robot itself, not on the cart that carries the suitcase. Okay, so the drop off location, the drop off distance is for the robot, okay, not for the suitcase. Now, what is an issue? Yeah, this is too generic, Jonathan. You have to do an assumption related to the problem itself. So for the assumption and the issue, we need you to go outside coding and look at an engineering problem and try to figure out what are assumptions and what are the issues from the engineering point of view. Okay, your client give you these specs, and you are dealing with it. Okay, so how you will determine what are good assumptions, what are the challenges we have. Okay, question so far, or we can move. What are issues that can happen aside from accuracy, motors, poorly written code, battery? Uh, yeah. Okay, this is an assumption. Okay, uh, but already it says this. It says that each somebody kicks the robot. This is not an issue. Okay, so this is a okay. So we have psychopaths in the airport kicking robots around. Obstacles. Maybe this is an issue. Okay. What other issues we can have? What are other issues we have? The car damage the robot. You are trying to use the issues that we luggage is too heavy. Yeah, maybe this is an issue. Luggage is too heavy for the robot to carry, or maybe the luggage dropped from the cart. Okay, you will not be checking for this. Okay, loading and offloading of the luggage. When loading the luggage, maybe it will drift the robot. Yes. Uh, so maybe yes, after reloading and the robot start to move, someone takes the suitcase. Okay. So there is no check if the suitcase will still there until you drive it or until you deliver it. Okay. So all of these are points to be issues. Okay. So uh, suitcase drop, loading and offloading effects on the robot. So you may move the robot or change its position or angle while you are loading and offloading, given that the motor doesn't have a brake. Okay, given motor doesn't have brake or brakes. So if the motor doesn't have brakes and you start to load the suitcase, you may be moving it forward a little bit or moving it backward a little bit. All of these are issues that can happen um, during the actual um, implementation. Now write a function that will receive an angle that is positive and use the robot to rotate, use the gyro to rotate the robot, the given angle. Okay, so we need to write down a function. So this function will return nothing, it's a void. And we can call this function as rotate robot. And this function will receive a positive angle. So int angle. And then what we have inside this function. Okay, so in this case, we will start by reset gyro, and the gyro is connected to sensor 2, reset gyro sensor 2. So we start by resetting the gyro, and we will assume, okay, we are in the standard configuration. So in the standard configuration, you have motor A and motor D. In this case, a positive angle will be this direction, which means A positive and D negative. So we will say motor A equals motor D equals 50. Okay, and this is an assumption here. Okay, so this can be a valid assumption that we are driving the motors at 50 power. So motor A equal motor D equal 50, but this is not rotating, this is moving forward. Okay, so we will drive this as 50 and negative 50. Is 50 is good power to rotate the robot? Or is that good power to drive the robot? It's too fast, yes. So usually when you are turning, okay, try to use low power, so usually 20. So here, this is what we are looking for, okay? We are not giving you numbers, but we need to see that for rotation, you are using lower power than driving. Okay, so we are resetting the gyro, we are moving or setting the motors. So while the sensor value of sensor 2 is less than the angle, do nothing. Also, we can say while the absolute of the sensor value less than the angle, do nothing. Okay. Here it didn't ask us to adjust the motor power, but if you do this, that's fine. You can add here that you are receiving an int motor power, and in this case you will say this one equal positive motor power, and this one equal -1 multiplied by motor power. That's okay. It didn't um it didn't ask for direction. Okay, it says assume that the angle is positive, so you don't have any direction here. So adding this is, you will lose marks for it, because already there is an assumption that the angle is positive. But adding the power, that's fine. They didn't say add it or don't add it, so adding it wouldn't hurt. But positive angle, so here no direction. Okay, make sense so far? Okay, now write at least one function that is non-trivial and the main program. Okay, so let's go back to what are the requirements, okay, to see what will be a non-trivial function. Okay? So we need to wait until a suitcase is in the cart. Then we need to drive the robot to the drop-off location based on the color. Then waits until the suitcase is removed from the cart. Okay, now here there is an assumption, correct? What is an assumption here? This is a valid assumption, you can assume. What is an assumption here? What's an assumption you have to make here? Is the question is giving you yes, so the suitcase will be removed when the color is 0, and also we can add some weight after it, okay? Because someone will take the suitcase, so the sensor will not see the suitcase while he's still offloading it. We shouldn't be moving our robot, we should wait a little bit. So we need to add some weight here. Okay, so here is a car, so someone will reach out to the suitcase and he will start to pull the suitcase outside. So your car sensor will not see the suitcase. Okay, so once you start to pull this out, your car sensor is not seeing it. Okay, so in this case, you have to wait. You have to wait a little bit until he takes it out. And this is an assumption. You can say, I will wait like 1 minute. I will wait 2 minutes. We can ask him to press the enter, but this was not given. You can do this an assumption. You will assume that the after removing the suitcase, he will press the button. But the problem here is that it was given to you that when the suitcase is removed, the color sensor will sense 0. So why we need to add an extra step to touch the button? maybe just wait, give it some time. So here we can assume, say, that 1 minute is enough to offload. Okay, it's an assumption we can do. Now turn the robot 180 degree. So here the robot will wait until you load a suitcase. Then from the color, you will go to the drop-off location. Then you will wait in this drop-off location until the suitcase is taken. Then what you will do, you will rotate 180 degree, and then you will travel back. Now, what is a function so far from here? Okay, what are functions here that we can write? We can design functions that will drive based on color, which will be driving a distance. Okay, so we can say we will write a function. So this function will be void, and this will be drive dist color, and we will call it with integer color value. Okay, in this case, what we will do, we will set n motor encoder of motor A equals 0. We will reset the encoder. Then we will say motor A equals the motor D equal 50. This will be the driving power. Or we can say we will input the motor power. Okay, and here we will say this is an int motor power, and here this will equal to the motor power. And while n motor encoder of motor A less than. Now don't forget that the color is giving you the distance, or the color when it is multiplied by 10, it will give you the distance in meters. Okay, so we will take the color value multiplied by 10. This would be the distance in meters. Okay, then we will multiply this by 100 to convert it to centimeters. Then we will multiply it by the conversion rate, 180 divided by 2.75 multiplied by pi. Okay, we will do nothing. And instead of having, I'm coming to this again. And instead of having this as this big value, instead of doing this, I will say this as encoder limit. Okay, and before doing this, I will say an int constant or constant int encoder limit, which equals to 10 multiplied by color value multiplied by 100 multiplied by 180 divided by pi multiplied by 2.75, and we can use it as constant. So while we didn't reach this limit, keep going. Then we will say motor A equal motor D equals 0. You will stop the motors, and you can add or you can remove return, because this is a void function. You are not returning anything, so the closing braces will exit the function. So this is a non-trivial function. Make sense? Make sense? So how the constant will change? So each time you are calling the function bin, the constant will be defined again. It's local. So each time you are calling it, it will be constant because you are calling it with a color value which is constant at your call. Okay, so each time you are calling the function, it is a constant. We don't have to define this as a variable. Make sense, Ben? Void means Jacob. Void means return nothing. Okay, we are not returning anything. So this is the type of the value you are returning, Jacob. So why do you have to use? You can add it or you can remove. So this is optional. Okay, we are returning nothing. Just we return. So this is optional. Nicole. So this is optional. You can add it. You can remove it. Okay, so if you didn't add it, that's fine. If you add it also, that's fine. Make sense? Can we move forward? Can we move forward? You have to go. Okay.
What the fuck?
Okay. Now we have this function which will derive a distance according to the color. Now we need to write. So we answered right at least one additional non-trivial function. Then the main program. Okay. Okay. So let's write down task main. Let's write our main task. So what will be the starting point for the main task? For main. Okay, so here we are given a function, and this function will be just configuring the gyro, okay? So we have a function that will configure the gyro. So I will call this function. Okay? So void configure gyro. So I will start by having a function that will configure the gyro. So we configure the gyro. Are we done with sensor configuration? Are we done with sensor configuration? No, just I'm sorry, just it is the main of it. Just I will write. Okay, so here we go. I copied it more. Okay, just I copied more than what I need. Okay, Rahul or Irina. Configure color sensor. Yes, we need to configure the color and the ultrasonic. Okay, so we need to configure both. So what we will do? So here we will say sensor type sensor one is sensor EV3 color. And here we are not that picky with which letters are capital. Then we will wait 1 millisec 50. Then we will say sensor mode of sensor 1 is mode EV3 color. Then we will wait 1 millisec 50. So this will be the configuration for the color sensor. Okay, so the configuration for the color sensor is setting the type, then setting the mode. Okay, then we will do the same for the ultrasonic sensor. Okay, so we will say sensor type, and the ultrasonic is connected to S3 equal sensor EV3 ultrasonic. Then wait 1 millisec 50.
Yep.
then sensor
Practice.
mode
Fifty.
S3
There's like 50 people
equal mode
out of 200 something. So.
EV3. Um,
Huh?
I don't think here there is mode for ultrasound. So just we set the
Close the
type.
door. Close the door.
Yeah, just we set the type. So this is the setting for the ultrasound. Okay, make sense? Now we finished the configuration of sensors. So what would be next after we finish configuration of sensors? Now if we read this, so the program will wait until we have a suitcase, then it will drive it a distance based on the color, then it will stop. When the suitcase is removed, it will rotate 180 and travel back. Yes, the color sensor has to be in color mode, yes. So because we are checking for colors, so it will return what is the color we have, return an integer value for all the colors we have from 1 to 7, with 0 is no color. Okay, Sydney? Okay, now the program will stop. So the program will stop if we reach 100 suitcases or we detect an obstacle in front of it. And this object should be detected on your way back. Okay, so we need to do this code for 100 times, then stop, or while you are driving back at any stage, there is an object on your way. In this case, you stop your program. So how we do this? Okay, so what will be the first part of my code? What will be the first part of my code? So the first part will be for loop. Okay, so for int suitcase count equal 1, suitcase count less than or equal suitcase count equal, sorry, plus plus. We will do the following. Okay, so we will do our code for 100 iterations, and in this case we can say an constant int number of suitcases equal 100, and all of these has to be capital. Okay, and here we will use this as number of suitcases. If we decided that we need to change this. Okay, we will come to this, Aiden. Aiden, I will show you a good way to do it. Not a break, okay? Okay, Aiden. Yes, you should reserve some space beforehand. Yes, Ben. This is so. Whenever you have a for loop or while loop or something, please leave a space before doing this, so you can go back and start to add or define constant. Okay, so before writing a for loop, before writing part of the code like here, you need to leave a space just in case you need to add something. Okay, it's a good practice to leave spaces. Okay, we will skip these spaces. Now let's go inside the code here. So what the code will do? So for each suitcase, we need to wait until there is a suitcase. Okay, so what we will do? So while sensor value of sensor 1 equal 0, we will do nothing. Correct? Then we can do await 1 millisec or 10 millisec. Okay, and we can wait 1 minute once we detected the suitcase, just to give some time for the operator who is loading it or offloading it. Just we can wait for 1 minute. So 1 minute is 60 seconds. So this is 60,000 millisec. Okay, so we can do as wait 1 millisecond 60,000, or we can do it as 60,000 of wait 10 millisecond. Okay, just here we are waiting 1 minute to make sure that the suitcase is there, and this is an assumption. Okay, so this can be done or not. Okay, if you didn't do this, that's fine. Now once he put the suitcase, okay, there's a suitcase, what we need to do? Once he bought a suitcase, what we need to do? Yeah, so in this case, what we need to do, we need to read the color and we need to use it. Okay, so what we will do, we can say here an int color value equal 0, and we can say color value equal sensor value of sensor 1. Then we can call the function, which is derive dist color, and we can call it with the color value, and this will drive the distance according to the color. Now it depends how you define your drive. If you added the motor power, okay, in this case I will define here a constant, int constant drive power equal 50. I will assume that I'm driving at 50. Integer constant turn power whenever I'm turning, let's say this is 20. Okay, so if we need, we can change this later on. It is just within the for loop. Why I define the color global. So each time I have a suitcase, each time I'm within this for loop, I need to know the color and I need to drive it. So I will call this with the drive power if I wrote my function to receive the power. Okay, if I didn't write my function to receive the power, just I will call it with the color value. Okay, Irina, makes sense so far? Any questions so far? You are following with me what's going on? You are following with me what is going on? Okay, good. Now what we need to do, so what this function will do, so this function, okay, which is our for loop, will take the robot and drive until the drop-off location. Okay, what we need to do at the drop-off location, we need to wait until the suitcase is taken. Okay, so once the suitcase is removed, we need to wait a little bit. Then we need to rotate our robot and start going back. Correct? Yes, so we will wait. So we will do while sensor value of sensor 1 not equal to 0, do nothing. Correct? Correct? Clear what we are trying to do here? Then we will wait 1 millisec. We will wait 1 minute to give some time to the operator while he is removing the suitcase. Okay. Now what we should do now? What to do now? Rotate function. So we will do our rotate robot. Rotate robot. We will rotate 180 degree, and we will rotate with the turn power. If I designed it to receive the angle and power, okay, so I will call it with the angle and rotate or the turn power. Now what we need to do next after we rotate? What we need to do next after we rotate? Yes, drive back the same distance. That's why I read the sensor value here into this variable, okay? Because once the suitcase is removed, you don't have the color anymore. That's why because some students will call the function with sensor value of S1. If you call the function with the sensor value of S1, you didn't save the color and you need it later on. Okay, that's why you need to read it here. Okay, so don't do this. Don't. Clear this point? So don't forget that while you are rotating, your motor encoder will keep counting, Sydney. So you should use the encoder from this point here. Okay. Okay, questions before moving? Questions before moving? Any questions? We are good? Okay, Ben, let's say that the color was brown, okay? So you notice 7, so you drove 70 meters. Now, you took the suitcase, so the color now is 0. How we will drive back? How long we will drive back? You don't have the sensor value anymore because the sensor value is 0. So, so you use the motor encoder before rotating and save it, then drive back until the encoder is 0, or you rotate and reset the encoder and drive back until? Okay, yes, that's fine. So let's say once I came from here, so once I finish this value, I will say distance encoder equal to motor encoder, okay, of motor A. Then I will rotate. Okay, so I will save the value here. Then I will rotate the robot, and after I rotate the robot, I will drive this distance back, which is fine. Or if I know the color, I know the distance in meters. Correct, Ben? Because the value of the encoder should match the distance in meters, which if you look here, already the distance you travel, the encoder limit is the color. Depends on the color. Okay. Questions? Okay. I'm not saying this is the only way. Please keep in mind, this is not the only way to do the questions. There's many other ways. Okay. I'm trying to give you an idea how you can do it one way, and we can discuss whatever you think of. Some students can use this as int, okay, and they can return the in motor encoder of motor A. In this case, you will say here you will call the function with the distance encoder. So I will return what is the value in the encoder after I stop. Okay, this will work too. Another option to do it. Okay, so just you need your logic to be correct. Okay, so this is another option. Okay, you can return the motor encoder as an integer and then use it to drive back. Make sense? Make sense? Can we move forward? Now, can we move back? Now, when we move back, wherever the drop-off point, we need to drive the same distance back, which will be easy without the condition given. So what I will do, I will drive dist again. I will drive dist again, color value, because I have the color value already. So it would be so easy to go back to the start point without the conditions they give. Just I will drive back the color value. Okay, but they give me a condition here which will make this not possible. That while you are driving back, if there is an object, you have to terminate the program. You have to stop. How we can do this? So we cannot do this. Okay, this is not valid. So what we need to do, we need to drive back, and while we are driving back, we need to make sure that there is no objects in our way. If there is an object in our way, we need to stop it. Okay, we need to stop. So what I will do, I will take this values here. Okay, assuming that I'm doing the color again. Okay, so I will start by resetting the encoder. Okay, setting the power to drive, adjusting the encoder limit, and here we will say while you are less than the encoder limit, you will keep driving, but you will add a condition here. What is the condition you are adding? So if we do this, it will drive back the same distance. We don't do, oh yes, or C, not or. And so while you didn't reach the encoder limit, so you didn't go back to start, and the sensor value of sensor 2, which is the ultrasonic, is the ultrasonic sensor 2. Sensor 3, sorry, is greater than. Now, what is the value we use here, which is considered as a good value for away, something away from you? Yes, 15 plus 20. So we can say, I would say 30, assuming 10 centimeter is very close. Okay, this is an assumption. And assuming that we have the standard configuration, so the ultrasonic sensor is at the back of the robot. Your robot is 20 centimeters. So we will assume that the object will be 10 centimeters away. Okay, so this is an assumption. So while we didn't reach it back the start point, and we didn't hit any object, we will keep going. Okay, so this number, it's up to you. Just we need a value greater than 20. Okay, so we need a value greater than 25. 20 for the robot, and 5 is the minimum distance that you can sense. So any value greater than 25 would be okay. Now, when you will go outside this while when you will go outside this while. Yes, let's continue. I didn't finish. Because Nicole, it says you drive back the same distance, but while you are driving back, if there is an object, you have to terminate the program. So if I use the same functions that I called for color, it is not checking for ultrasonic. I cannot use it. So I need to drive back the same distance, yes, but if there is any object, I have to stop and terminate the program. So this is a modification on my way back. And it said that you have to do this only on your way back. Only. You have to do this only on your way back. Okay, Nicole? Renato? Make sense? Nicole, you understand what is the problem here? Okay, Renato. Now, what will take us outside this while loop? What will take us? Don't forget that this while loop is an infinite loop, okay? So you keep looping until you go outside. Okay, so when you will go outside this loop, what conditions will take you outside this loop? If 30 centimeter away from an object, or we reach the start point, or we reach the start point. Okay, now if we reach the start point, what we need to do? Rotate and wait for back again. What if we hit an object? Yes, so stop permanently. How we do this? I will do the following. So if after I go outside, I will check if sensor value of sensor 3 is less than or equal 30, I need to end this. Else, I will do the following. Okay. So if I hit an object, yes, exactly, Sharon. This is what I'm going to do. So if I am inside this if condition, it means that I hit an object. So what I need to do here, I need to terminate the program. How I will terminate the program? I can say that the count of suits plus equal the number of suits. So what this will do? It will increase my counter by the total number of counts, which is 100, which for sure will make me terminate. This will make me terminate the for loop. So it will make me terminating the for loop. In this case, I will have motor A equal motor D equal 0, and we are done. Clear how I will make it to exit the program? So if I hit an object, I will make my counter, I will increase my counter by the total number of count, which will make me to exit the for loop, because the for loop is for the value less than the total. So if I'm adding the total to my value, so I will exit the loop for sure. Clear how I did this? Clear how I did this? What if I terminated this here, not because I hit an object, but because I went back to the start point? In this case, I will rotate the robot 180 with the rotate power, and I will go again outside the for loop, okay? And I will stop my motors, then I will go outside the for loop. So I will wait for another suitcase, then I will continue to do the 100 suitcase. And this would be the code. Make sense? Can we also do if absolute increment of increment limit, encoder limit minus traveled distance? But in this case, you have to initialize the object detected. Okay, Jonathan? In this case, you have to initialize the object detected. Because to get into the while loop, you need to make sure that you will get it into it at the first time. But it would work. So you can use a while loop instead of for loop, and you will increment your counter inside it, and you can add a condition that there is no object detected, but you have to make sure at the beginning that no object detected. Yes, we used the motor encoder in the way back because we cannot use the drive color dist function. Yes. Yes, we can do this, Jonathan. Yes, yes. This is another way to do it. Yes. Make sense? So this is one of the. So Robot C, all the examples are good examples for Robot C. Questions? Okay, by the way, Jonathan, you have to add in your functions that you will call, you have to add that you didn't hit the ultrasonic. So you will use the ultrasonic while you are going forward or backward. Okay. But the problem is, are you going to check it in the backward? Sorry, on the forward. Why so this is Irina, this is like safety. This is like for safety. To make sure that when I'm exiting, the motors are turned off. Okay, questions. Questions. Any questions? Okay, so yes, the total length of the robot can be assumed 20 centimeters. Bumper to bumper. Bumper to bumper. Okay, I hope this example was useful and helpful today. Thank you for attending. I'm available tomorrow 9 to 11 a.m. for office hours. So if you have any questions, feel free to drop by my office or call me on Teams. Have a good night. Thank you so much. Thank you. Have a good night.
If I have a quick question, can I stay back?
Yeah, for sure. If you have questions, you can stay back and